So I just want to introduce you to the organizing team. So here from Trifork, we have David, Simon, Julia, and Martin. If you think Simon looks familiar, he was actually part of Orbit Lab for a while until Trifork decided to steal him. My name is Lida, I'm the community manager in Orbit Lab, and with us today we also have Kasper Silber running the technical stuff. It would be nice if all of you would comment, put in the comments where you're from, who you are, and where you're listening from. Yeah. So also just to let you know that Trifork is one of Orbit Lab's founding partners who've been with us since the beginning. And we're so happy that they want to do fun stuff with us for you in the community. So this is the program we have to get through today. The idea for today is to prepare you with all you need to know in order to put your team together and start training. So in Orbit Lab, we do have one donkey car, and in Trifork, they have 3 donkey cars, and you're welcome to come and practice both in Trifork and in Orbit Lab. And of course, we will let you know once we have a date for the final race or the race next semester. You're welcome to post your questions in the chat during the talks, and also at some point we'll be training the car, and that would be a good time to ask questions as well. So with that, I'll leave you in the capable hands of Simon.
Hey guys. All right. Like Lita said, we are really happy that this is actually happening and we can do this. So I hope it turns out great. Yeah, I'm Simon, by the way. I didn't mention that. I'm a software engineer at Trifork. I would like to introduce you a little bit to Trifork today, so you know what it is we do and why it is we are having this talk and why we're even looking at donkey cars in the first place. And I'll also tell you guys about what is a donkey car and how does it work, how do you collect data, and how do you train a model. And my colleague David will tell you about some of the machine learning behind the donkey cars. Trifork is a software company. We build software for our customers, and we have this mantra that we would like to make the world a better place and like to make everything easier for everybody through software. We are situated in 10 countries with 47 business units and 800 employees. So quick math would say that that's about 5 business units per country, which is a lot, some would say. That's because we have this magic number called, that whenever we are 42 in one business unit, we will divide in smaller units so that we stay small, even though we are getting big, and we keep it close. So one of the nice things about that is that you, in the business units, we know all our colleagues, and there's a really tight bond. So I really enjoyed that. Yeah. So this talk is about machine learning, and we are going to talk about some of the cases that we have worked with in applied machine learning throughout the years, and we have helped a company build a toilet recognition service, I guess, so you can find out which model your toilet is, and this particular company needed that for their business. And we're also working a lot with natural language understanding in this software called Dialogflow. It's a Google-made framework where you can train a voice bot to help solve problems. So it's about creating voice interfaces to anything, really. So if that's something you have interesting, feel free to ask questions about that after the show, I guess. Yeah. So what's it like working at Trifork? We are like a family, and we, like I said, we have small business units, and we know everybody, and we have this great thing called family training, where some of us go down and meet the founder and talk about what some of the values of Trifork is, and why the number 42 is a thing, and why it's called software pilots, and so on. We also have study groups where we dive into new software and technology to find out if it's something we can use in the industries we're working with. We also go skiing sometimes. Right now, not so much, but I don't think anybody is. So yeah, we also have hacker days actually, and this is where we started looking at donkey cars because it's a cool way to find out how this whole automated driving is working, and it's very practical. Yeah. So if you think that's interesting, you could always check out talent.trifork.com to see if we are hiring. And right now, in fact, we are. We are looking for front-end developers here at Dokken, where we are streaming from right now. So go and check that out if that has interest. All right, so this is what we're here to talk about, the donkey cars. And what is a donkey car? If you Google it, that could be a bit of a maybe confusion about is there donkeys? Is there carts? Where is this? But it's actually fairly simple. You take your RC car, remote controlled car, you take a Raspberry Pi, and you take your Xbox controller, and you duct tape that together, and boom, there you go, donkey car. Any questions? All right, so I'll show you. I have one right here. All right, there we go. Let me know if this is too small to see. But this is how a donkey car looks. And this is actually a very standard way of building a donkey car. This is the recipe that the donkey car site actually recommends. We have bought this RC vehicle down here. I can't remember the name, but there's a link in the donkey car site along with this donkey car kit. And the donkey car kit is this 3D printed chassis and a hat for to interface with the motor and the servo on the RC vehicle, and a bunch of cables. And yeah, we bought this one from Amazon, I think. But yeah, so we have you can actually see that here. We have a motor here, and we have a servo over here. I don't know if that's obvious to see. It's moving when I'm driving, yeah. Okay, and then we have the Raspberry Pi. So basically, we're interfacing directly to the hardware down here through this hat. And on this Raspberry Pi, we have the donkey car team has built some software that can collect the data and also send data to the motor and the servo, so we can control it through a Xbox controller that I don't have here. So, of course, this has to be with the Bluetooth enabled and Wi-Fi enabled as well in the Raspberry Pi. And it also has a camera. So the way it works is that you use the Xbox controller to control the throttle and the angle of the wheels, and then we drive it around the track and collecting data. And then we take the data from the wheels and the motor along with the camera image, and we label the image with that data. And then we create a model from that. And all this is actually explained in some of the guides that we have actually made for this event and also on the Donkey Car website. So yeah, let me just check the next. Okay, so this is actually what it sees and what we're talking about here. So you can see in this image, I'm just going to put this down. We have a picture of what the camera sees, and we have a JSON object on the right, where you can see the angle and the throttle and some data about this particular time where this image was recorded. And if you notice, this road is turning to the right, so that means that the user angle is actually all the way to the right because the vehicle is trying to turn right. And in this picture, the road is straight ahead, so the angle is 0. So it didn't affect the servo at all. Yeah, I think you get the picture here. But actually, we would like to show you guys. So we're having a live training session over here. So we'll just go over to collecting data.
And Julia, is it ready to go? All right. No. Restart it.
Yeah. So what we're doing now is we are doing 2,500 pictures. So we're going to drive around the track for a while and collect some data. And afterwards, we will train a model on that data. And we will see the car driving, hopefully. So yeah. Yeah.
Okay. Here we go.
And this track is actually very, very basic track. We just bought a couple of these fitness mats. I think it was a beam tamer, and then we spray painted the track on them. And we made it in a clever way so you can actually model it Yeah, so it's very easy to set up. I also just used the shop at home on the Paris and just wrote it on there, and then it worked fine as well. So it's all about getting some nice contrast. But you can see Martin has been practicing this. It's very still. Yeah. And if you have some questions, now it's the fine time to answer. I guess if Lida is looking into the chat, so just write them there.
Yes, there is a question.
Yeah.
Should it be able to drive by itself?
Yeah. So the point here is that we are collecting the data now, and then we're training a model that the software on the car is using to drive the car. So we're teaching it right now. We're teaching it how to drive. So yeah, so it has a picture where the track is going to the right, and it will see that the angle of the wheels are to the right, and then it will learn doing that. So hopefully in a few minutes we will see the car driving by itself. And actually you can also, now we are using an Xbox controller, but you can actually also use a PlayStation controller if you want. It's a bit harder to set up. And I actually also think you can use a web interface that's built in that we will show you later while we are going through the commands you have to write in order to make this work.
And we have another question. How long should it drive for?
Well, that depends. So how good of a model do you want? So this is about the amount of data you want to collect. And this one is collecting 10 pictures per second. So I think this was around 2,500 pictures, which is fine for a track this size. But if you want a really, really good model, you should, of course, use a lot more data, which you will hopefully find out when we have the workshop where you get hands-on. And
there's also a follow-up question. How much better would you expect it to become if you drove it, for example, for an hour?
I don't think necessarily it gets that much better. I think diversity of the track is what makes it really good. So if you have different tracks and have a more complex track than this one, you'll get a better result because you have more diverse data.
We'll get more into this later in machine learning talk.
Yeah.
And I think this will also perhaps be the case for the next question, which is what learning model do you use?
Yeah, we will get into that. I'll have to get out.
So maybe we should switch to actually see Julia's screen. Because what's happening right now is that we have trained, or I mean, we've collected data now on this. We've collected data on this Raspberry Pi that's on the car, and we've transferred data over to. No.
We haven't transferred the data. I'm going to do that live.
Yeah, so I'm just gonna show you how it looks when it's recorded. They end up in two folders called tubs. So the latest one we have is this tub 2, and there's like 2,700 images and 2,700 JSON files, and it will take forever to simply transfer these. So the easiest thing to do is to simply zip them, and then you can just copy the zip that's much faster. So that's what I'm going to do now.
The volume isn't that great. We can't hear any of you guys.
Can you hear me now?
Very low. It's like something's covering up the microphone.
How about now?
That's better.
Okay, thank you.
So I'm just gonna make a huge zip file, and let's see if I have it. Yep. So I just made this demo zip file. I'm going to transfer to my computer now. And once that is transferred, I will have to unzip it twice because such is the life of a Windows user. So now we can also see the images that they're very, very small on my machine, but this is what the camera saw when we drove. I can zoom, but the quality will not be very good. But yeah, this is exactly what the camera saw while we were driving on the track. And well, yeah, 2,700 of these. The images and the JSON files are going to be used in order to train a model. We are using Anaconda in order to train that, and I already have a command here for training it. Just have to select the right tab, and what should we call this model? I know it's very small to see what's happening on my screen. I'm very sorry about that, but it started training now, and perhaps David wants to say something about what's happening on the screen.
Which one? That one? No. Right. So some of you might know this. This is the typical TensorFlow showing how we're training and the loss is decreasing. It's running through the epochs, and at some point it will stop when the loss doesn't decrease by as much. That is, of course, I will get more into this, but that is, of course, chosen in a configuration file, which is more specified in the manual or guide that we have sent out to you guys. It's very simple. And at some point, the model will stop training.
So when will it stop training? Can you talk about that? Like,
yeah.
What is it?
Well, this model is using something called early stop, which means that it has some sort of difference in how much decrease in loss we want to see at each epoch. And then from what I remember, this model is set up to, after 5 epochs, if the loss hasn't decreased by a certain amount, it will stop. As you can see now, there we see the graph with the training loss and the validation loss, the validation being data that we haven't trained on. And this graph actually looks pretty nice, with the validation not being too different from the training accuracy. So yeah, there's the model.
So we have a model.
Yeah.
We have a model, so let's move the model to the car. I will put that into a folder that's called models. As you can see, we have quite a few of them. And now we're ready to drive the car with the model we just trained. So in order to start the car with the model, you have to use the same Python script as you used to just start it with the controller, but instead with the model command. And we call that one demo.
So now we're instructing the car to drive with the model.
Yes.
Instead of a joystick.
And once it's started, I think that's it. So this image here is a live feed from the camera, and you can see David saying hi. So I think one of the most important things you have to remember when you do this is that if you want your car to start, you actually have to go in and say local pilot here, and then it will just drive by itself.
So, Martin, are you holding a controller right now?
I'm not doing anything.
Not doing anything?
No.
Nobody can see that.
Okay, I'm not doing anything.
Yeah.
It's actually driving really slow.
Yeah. But you taught it too. So.
Yeah.
And then we can talk a little bit about this web interface we're looking at. You can actually also steer the car from in here. If you don't have a Xbox controller, you can use this to steer the car if you have an iPad instead or your phone. It's like a touch joystick where you just put your finger down and it will turn the vehicles. And it's not that easy to steer, to be honest, but it's doable.
All right.
So
We may have run out of power on the car.
I think it's missing power actually.
Yeah.
all right, we have another battery right here.
Okay.
Yeah.
It's not running.
Vil du have den
It's
her?
out of power.
Skal vi lige skifte batteri?
Ja, hvis det er det.
Det er det.
Nah, I think it's all right.
Yeah.
So let's switch on to the slides. So when we trained the other models yes, before we were live, we were actually testing this, and the model was running a bit faster. And one thing you might have noticed is that we were only training it one direction on the track. And if it still had juice in it, we could probably see that when I turned the car around, the car wouldn't be able to know what to do. Like when it would go to one of the corners, it would just drive off the track.
Maybe we can try it after your presentation and see if it has any juice on it.
Yes, we can see later and see if that's still the case. This. So yeah, I'm just gonna talk a little about like small, very general overview of the machine learning with the donkey cars, and I'm basically going to be talking about three things which are very general for machine learning, and that is the machine learning models, and also the data, and model training and evaluation. So basically, when you're training a machine learning model for any case, could it be like specifying what kind of toilet you're using or driving a car around the track, then choosing the model can be very important. Basically, you need to think about like some models can be good for certain problems. Some examples of these are recurrent neural networks that work very well with language modeling. If someone have heard that before, that is basically a neural network which uses the previous output as an input for the next step in training. So basically, when you're talking, the meaning or the context is very important for the meaning of the current word that you're speaking. So that, and then, for example, convolutional neural networks have been shown to work very well for images, which is also being used with the models for the donkey cars. So basically, differences in what input do you have and how does the network or the neural network look, which is just one thing of machine learning, and also the output. How do you want to model the output? For example, with the donkey cars, you're modeling what is the throttle and what is the steering when you're seeing this current picture. For the donkey cars, they have given a lot of like pre-made models that you can train yourself using the data. It's basically just a configuration file where you specify which model you use. And there's more than these. For example, one is the behavioral model, which is just has an image as an input with the throttle and the steering. And the output is a distribution of all the values of steering and throttling. So basically, you have percent chance that the throttle should be at, I'm not sure what the numbers for the throttle is. It's 0.25 was, I saw that.
1 to 0.
Yeah, 1 to 0. And also the steering, what angle should it be? And then like you have a distribution of how certain you is it should be some percent of other. And this kind of gives you a confidence in each choice, and you can actually use that to specify which to pick. Also, we have been using the Keras linear model, which is very simple. It's been shown to work very well, and also has no arbitrary limits to steering and throttle, because it only outputs two outputs, one for throttle and one for steering. It has been shown, and this is also available in the Donkey Kar's documentation, that it fails to learn throttling very well, which we might also have seen here, where it wasn't very good at knowing when to go fast, which also can be modified by using another modifier in the configuration where we can multiply the throttling. And the last one in this list is the Keras RNN, which is recurrent neural network, which in general is a sequence of images. So you're using what the car have seen in the previous images to kind of have an effect on what choice you're making now. And this might have a benefit, but the basic thing about machine learning is it's very difficult, and it can often be a very black box on like what works and what works. But you can try to explain sometimes why something works better than others. And another part of machine learning, and also basically the biggest part, is data. Data is the core of machine learning. Basically, if you're working with machine learning professionally or just in your free time, then gathering and preparing data is in most cases the vast majority of like what you will do when you're training a model. And also preparing data is very important in this case, because just gathering raw data might not work very well. That comes in that you have good and bad data. Like some data can be messy. You can have a lot of statistical noise. For example, we could have Martin be driving off the track, and the donkey car actually allows you to delete previous pictures taken when you make a mistake. But one thing that might have been good if you actually had data that showed the car going back on the track, then the car might be able to, when it failed, get back on the track in good time. Also, different data is very important. For example, we see it with our case where we are only training the car in driving one direction around the track. That wouldn't work on a different track or when it's driving just the other way around the track. This also means that usually you can have overfitting if you don't have a lot of different data. Also, just about gathering data is also very important. In our own experience, we tried attaching the camera at a bit higher angle and turning the camera more downwards so that it would see the track more and not have other things in the picture of about the people. Also, I've read that polarized lenses might also work very well if you read blogs about donkey cars out there. And the last thing I'm going to talk about is like model training. So some of you might know about these different things I'm talking about here. Like you need to test different parameters. Like we only tested some parameters that we know worked for this track. But in general, you should, when you're training a machine learning model, you should try and do some evaluation on what does the learning rate do, which optimizer to use, using something called early stop that I was talking about earlier. And also dropout is a very often used thing to mitigate overfitting. I'm not going to really go into all these different things about machine learning, because it can get very technical and very boring. One thing that's also interesting is that donkey cars actually allow us to use a simulation to train a donkey car if you don't have the money or the time to get a physical donkey car like we have. I have the link in here if you want to try it yourself. We haven't tried it ourselves, so we can't really help you with using, but you might be able to find a way to do it, and that could be interesting. Let us know if you get it to work.
I actually have a comment here because we tried a different department in Trifork tried to use another device than the Raspberry Pi. They used the Jetson Nano instead, which has a dedicated GPU. They struggle a bit with it, but I think that's a very good approach to get some more processing power if you want to train on the devices. But we didn't. didn't try to train on the device because it didn't make any sense.
Yeah.
Okay, so as far as I could tell, most of the questions that you posted prior to David's talk have been answered. But if you feel like you haven't got an answer for the questions, please post them again, and I will read them out loud.
There's a few of you who've asked what happens on a different track. And I hope we can just demonstrate that, because we just take the track we have and reverse it by turning the car around. So
Yeah, maybe we could show the track again.
now we have more juice.
So you want me to start the car?
So yeah,
Yes.
can you start the car?
All right.
Well, you have to wait.
Just a second. All right.
Now it's going the correct way.
Yeah. So this is the right way, or the way we trained it to drive.
And now the car is driving a little faster because we put in a new battery. So we put in a recharged battery. So now you can see that it's actually driving fairly well, rather fast, and it keeps within the track. So now we can try and reverse it.
Yeah.
And that's what happens. Yeah.
Yeah.
And just in general, like for any other track, this data we've trained and also gathered only in 5 minutes probably wouldn't work very well. So the idea is to kind of figure out a way to gather good data, which will allow you to work on many tracks. And that usually involves gathering more data, but not gathering more of the same data. So for example, your question is with, would it help to drive the car around the track for an hour? That probably wouldn't help. It could be very good at driving around this track, but as soon as you put it on another track, then that might not work very well. So for the physical event, which we are hopefully going to have at some point, it would be a good idea to try and think about how could you gather data that would help you drive on more tracks than just one. And sadly, we can't just tell you what to do, but it's always very interesting what solutions people come up with.
And we have a few more questions. Should it work on multiple tracks? What are the different output nodes represented in your model?
The output nodes? For our model, it's one node for steering and one node for throttling. And no, it probably won't work on other tracks.
And another question here, moving the same track into another room, would that work? Or is there too much non-track in the images?
That's an interesting question.
Yeah, that's interesting. We actually don't know. It might. For example, like we talked about, we tried to turn the camera a bit more downwards in another test. That might actually help it work better in another room. But we don't know whether they're using some of the other parts of the room to actually know how to drive around this track. There is a lot of work being done on machine learning and trying to explain why a model does what it does. But as of now, that is still not a solved problem. Hope that answers your question.
What about if you move the Trifork banners? Would that make a difference?
You can try. Yeah, we actually tried having the Trifork banners closer to the track at the start, and you might have noticed that the Trifork banners have the same colors as the track, which is black and white. And when we trained it there, it didn't work very well. So yeah, so we moved them actually further away. And as you can see, they don't do a big difference on on the model.
Yeah, Matthias is a little disappointed that it still works.
Yeah, that just means the model is robust in a way. That is actually training on the track and not on whatever it sees outside.
But we need you guys to do better than this. So you should come up with ideas on how to improve on this performance so that you actually win when we do a contest.
Yeah.
Because there are lots of ways that you can actually tweak this model. Do I need to go further in here? All right. So I just want to say that there are lots of ways that you can actually improve this. I don't want to give too many hints because I think you should also leave this as an exercise for the viewer. So I don't want to say a lot about it, but you can tweak the data.
You can choose a different model.
Yeah. So please try fiddling with this and get your own experience from how to improve this. And then hopefully we will see you later.
So Troels is asking that it seems like we're using supervised learning, which means that you have to collect the label data by driving the car around the track. He was hoping for a reinforced learning model. Is that available in the simulator? Yes, it is. You can use that in the simulator.
We haven't tried it. So.
Yeah, we haven't tried that.
They should try it.
But you should try it.
Okay. So I think that was about all we had for you today. Of course, we will let you know when we're ready to have the big race next semester. Every great contest has great prizes, so there will be some of those too. And don't forget that in the meantime, you can come to Orbit Lab, you can come to Trifork here at Doggen, or Dog 1, as some like to call it, to do your training. So start putting together your teams, and thank you very much from all of us here at Doggen, and we wish you a great evening.